Now we are about to commence a online session, Dr. S.M. Patil Memorial Lecture delivered by Shri Sanjeev Rastogi. Now I would like to invite the session chair, Professor V. Radhakrishnan, to start the proceeding of the session.
Good afternoon to all of you. Perhaps I may have to give an introduction to what is meant as S.M. Patil Memorial Lecture. Many of you may not be knowing S.M. Patil because you might have heard about HMT, not the current one, the earlier one. He was the managing director of HMT, and he was the person who made HMT what it was earlier. Unfortunately, it is not doing very well in the present times, but then the effort put in by S.M. Patil have been acknowledged worldwide, and especially when he started the manufacturing of machine tools by collaborating with Czechoslovakian industries. At one time, even before other machining centers came to India, designs of different types of machining centers, both horizontal and vertical, were done by HMT Pinjore, and very good lathes were produced by HMT at Kalamassery, and other machines were mostly confined to the field of manufacturing. They were produced at Bangalore. Today, HMT is not a very well-known brand name, but I am sure that it's possible to revive that industry and bring it up to a level of competence whereby we can be again proud of this trademark HMT. Now, I have great pleasure in introducing the memorial lecture speaker, Shri Sanjeev Rastogi, and a brief biodata of him will be presented. Shri Sanjeev Rastogi, born in 1969, is currently working as General Manager in Corporate Capital Investment Group of BHEL, New Delhi, and taking care of modernization needs of its manufacturing facilities as well as assets. He is a BE in Electrical from MNIT, Allahabad, and MTech in Power Electronics from IIT BHU Varanasi. He has over 30 years of experience in various aspects of manufacturing in varied areas from turbines to transformers. He has led teams up to 300 members for managing complex projects for establishing new products and processes and improving the efficiencies of operations, like establishment of 700 megawatt nuclear turbine manufacturing without much of a capex and achieving 3 times the turnover by adopting his technological competence. He has been a VSM champion and granted 3 patents till date. Presently, he is also spearheading adoption of Industry 4 in manufacturing and representing BHEL in various external committees and forums. I welcome Shri Sanjeev Rastogi and request him to present the memorial lecture in memory of Mr. S.M. Patil.
Thank you, Professor Bhargav. And a very good afternoon.
Yes, so you are not audible now.
Very good afternoon, members of the academia as well as the students who are the future patient builders. I will just share my presentation. Basically, very good afternoon once again to members of the fraternity, BHU fraternity, being an alma mater. I am really privileged to be connected to BHU here. It's a topic, as I have discussed already mentioned, that is heavy machinery in capital goods manufacturing. I just give a brief overview of the BHL experience in that. Just to start with, I'll give you a glimpse of BHL, Bharat Heavy Electricals Limited, through a video.
Yes, sir, it is not visible. Thank you, sir.
You understand life's bigger battles. unique possibilities in all those sectors of the economy. The strength of our unmatched engineering, developing and manufacturing capabilities has been driving India on a journey of continuous evolution, both in the spaces of traditional forms of energy and fossils, as well as the current shift towards green energy, backed by a long-standing legacy, green power, industry, transmission, transportation, renewables, oil and gas, defense, aerospace, or energy storage. We enable outcomes that culminate from powering ideas into reality, bringing forth solutions that are not only relevant today, but also define the future. Moving forward in a journey that is outpacing the world's transformation from fossil to green, fueled by innovation, we are powering growth, enabling global partnerships, steering progress, nurturing dreams, and building a better world. BHEL is a talent and capability behemoth that has leveraged the nuances of time, resources, and refined engineering to gain uncontested expertise in the areas of equipment design, manufacturing, testing, after sales, to create some of the world's biggest and most acclaimed manufacturing partners. The company's 16 state-of-the-art manufacturing facilities spread across the country manufacture equipment compliant with national and international standards, offering it a strong product portfolio that spans across a gamut of industries and sectors with footprints in 89 countries. Behind its manufacturing prowess is BHEL's deeply rooted yet continuously evolving R&D. The company earmarks over 2.5% of its annual turnover for R&D spend, making it one of the highest in the capital goods manufacturing industry in India, with over 75 global technology collaborations and a strong overseas footprint. BHEL has already been on the forefront of knowledge and technology sharing that goes beyond boundaries, presenting the mettle of its capabilities to the world.
Welcome back. This was just a glimpse of what BHEL is, and we all know. Just as mentioned, there's a footprint. So give the details of the footprint where BHEL is, with 60 manufacturing units and service centers spread out throughout India, and a product portfolio across the range of infrastructure, power, transmission, transportation, defense, industrial and renewables. Details of the products, just a glimpse of it. In this, I would like to mention that hydrogen basically is a new sector in actually. There are other sectors also there like electrolyzer, composites, etc. And for that I'll come later. This is basically, am I audible? Hello?
Yes, sir, you are audible.
I'll come back again. So the voice was too quiet. Basically, in this, if we go by the topic, to set the context, I am showing the typical jobs that we are doing. Otherwise, the various types, pattern, the drums, etc. And for that, the basis is our manufacturing facilities. Just a glimpse of it. Major ones that are captured. Basically, our heat, hardware plant. Some of that lays vertical borders, huge ones, 10 meters. Then gantry milling, slot milling, CNC. Then OSBT, OSB balancing tunnels, 5-axis CNCs, etc. Just a glimpse of it. Then robotic caping machine. Gantry milling. special robotic coating facilities, etc. Basically, this is just a glimpse of what BHL is and how it does, and what machines you are seeing. That is what makes a capital goods. That are basically examples of capital goods that we are making. The end products that we are making is now coming to the details of it is basically the sector part of it, the capital goods sector, and its growth drivers. First of all, let's see what's capital goods. Capital goods are machines that is used to produce goods and services. Basically, they are not equipments to be used as a consumer. It has multiple effects on the development of country's economy. In this, the import-export ratio is of the order of 3x. That is, it is 300% basically the amount imported, and contributes to India's import bill substantially. Around 12% contribution it gives to the total manufacturing, and provides around 2% GDP. And in the nowadays, in the China one is the requirement. As mentioned yesterday by our honorable finance minister, it is the second most sought after manufacturing destination now. In that, the potential of exports is of the order of 1 trillion by 2030 and 20 trillion by 2047. With massive push on infrastructure and the government schemes of PLI, 100% FDI, etc., this sector is bound to grow leaps and bounds. But all is not that rosy in this sector, because as we see, the execution times are squeezed. At one time, we are executing the power plants in 60 months. Now the execution time is coming down 36 months, 40 months. Similarly, the reliance on fossil fuels with COP28, we have to reduce. And then ultimately, the heavy engineering sector, which has been focused on power, on thermal power and fossil fuel based power, have to shift to cleaner renewables, to nuclear. Similarly, the stricter technical and quality norms are coming with each product. We also are very sensitive to the quality norms that are being followed. Then the fast changing market requirement and product options calls for rapid development of new products, increasing competition. And what is happening is it's a vice versa. Competition is increasing, but the manpower cost is improving. And in that, in the heavy engineering sector, it accounts to almost 20% of the total cost. Then the supply chain interruptions are there that were predominant in the COVID period. To overcome these, we find there is only one thing: continuous modernization of manufacturing technologies. To be able to sustain our existing business with the increased competition and the increased quality levels, and focus on new diversified areas. It is bridging the manufacturing through procedures. Basically, we bridge the manufacturing technology gap through two modes. One is capacity augmentation, that means the state-of-art facilities that are there available in the market. And second is, but this is a very costly option. Second option, which is much cheaper, is upgrade our existing facilities to be in league with the state-of-art ones. And to be in step with the market, you have to diversify. You have to leave off the old redwoods and move to newer products in the sunrise areas. Wherein nature is venturing into aerospace, defense, and the latest being into coal to methanol and coal to chemical, and the electrolyzers, that is hydrogen, and composites, and advanced propulsion. Vande Bharat is one area you may have heard that we got an order of 25,000 crores. Then ultimately reducing a manufacturing cycle time and cost through number of concepts like VSM, value stream mapping, lean, 5S, 6 Sigma, etc. Removing production bottlenecks that are there through meta study, work study, various phenomena are there. And adoption of emerging technologies. Last part, I feel that is the most important is if we don't follow the emerging technologies like additive manufacturing, the IoT, as well as the robotics, etc., we are bound to fail. Basically, this gives a roadmap how BHL follows the augmenting facilities. I won't go into much detail. Then I'll give a glimpse of what facilities we have created in the recent past. We have constructed new blocks, we have done procurement of new machines, etc., plants, etc., everything, and established new process plants. Just a glimpse of it. In the recent last 5 years we have done this. It's a new transformer block that we have built up in Bhopal. Internal view of that, it caters to 765 kV transformers. And for this is on SRGM, for naval guns as it is clear, and this for clean room for electronics items. Similarly for hydro turbines, so we are building up number just to give a glimpse. These are the new machines that we are going into. Now, basically procurement of new machines is easier said and done. But what about our old legacy machines? We are into the business in 60s. The oldest plant that was established in Bhopal was established in 1958. So we have started with legacy machines. So basically, to optimize on the cost, we move on twofold path. One is new acquisitions as well as upgrading our existing machines. For enhancing man-machine productivity, low-cost automation of manual operations, then removing manufacturing bottlenecks, etc., and low-cost indigenous development of special-purpose machines and systems for meeting the purposes and increase connectivity of our machines equipment in line with Industry 4.0. Just examples of the modernization trends that we do, at the low-cost things we do, like you see in this system, a clamping system that for welding of the rings in 4 parts of diameter 5 meter to 6 meter. We have to use a crane. Instead of that, we have designed a system under it. The total movement, material handling in the bay has improved. The total cycle time of other jobs have been reduced drastically. Similarly, the low cost stage that were the studies of older machines that were there, which are used as scrap, you see the condition. That one has been converted into a machine, horizontal molding machine, at a cost of 30 lakhs only. Similarly, a lot of SPMs have been developed in the recent times, and we are taking use of that. At very low cost, we are doing it at even 1/10 of the cost. Similarly, further coming to the last part of it, the most important part, emerging technologies under Industry 4.0. As we are there, causing a drastic, as you all are aware, these are causing a drastic shift in the way we have been doing the manufacturing. Like IoT for predictive maintenance of large standalone machines as well as an array of machines and plants. And robotics in each area of operations, where are there hazards, where there is the cost aspects of that in the given conditions is to be taken care of. The third is the additive manufacturing of complex components. The main benefit that we are finding of additive manufacturing is cutting down our cycle time of prototype development. Because additive manufacturing right now for standard jobs is a bit costly, but for complex jobs of exotic materials like titanium, vanadium, this becomes, and in this we have a tie-up with IIT Kharagpur, COE, and we are moving ahead. along with certain private players also, and you are doing it. Similarly, the CAD/CAM integration part of it, we all know. Then automated inspection, AR, VR, and advanced material coatings. These are other lines that we are executing. Give a thrust of what IoT implementation we are doing in this is basically for predictive maintenance of connected machines, the CNC machines that are there, we have connected almost 85 of our critical machines across 16 units in BHA through a central hub in Delhi. And everything is, the utilization, the breakdown is available on the dashboard. Similarly, we are doing for inventory management, then design and manufacturing integration, material handling, and even for electrical management, substation management, the switching, etc. It is all being done through IoT. So that we don't have to go to a circuit breaker to trip it on. It can be done from this common console at the unit. Ultimate goal is the paperless factory. For that, we have developed we have tried out because we are started with the legacy machines. None of the OEM systems that are available, including Siemens, Palo, ETC, etc., were suitable for us. We tried a lot, but ultimately we went on for our homegrown system for IoT, and that is Mola. It was showcased in Hanover also, and in that case, basically, you see from that visible that the machine operations are visible and all the units connectivity we can link up all the machine units and see what is the situation of the machine, condition of the machine that are there. And any breakdowns that are come are predicted beforehand so that the cost of the downtime as well as the cost of the spares is minimized. Also, we have been able to improve, like in that we have been able to reduce the power savings by around 4%, the breakdowns by up to 10%, and the long breakdowns have been improved drastically. Further, in some cases, even the process quality has improved by up to 400 to 600%. Further, the cycle time have also reduced as a reform, and overall efficiency of operations as well as the transparency is improved because even the same is available at the head of the unit. The style of all the critical machines is available at the head of the unit. Similarly, we have used it in we have drawn a digital twin of our VPD vessels, which is vapor phase driving vessels, which is heard of for transformer manufacturing, power transformer. And in that case, we have been able to predict the amount of moisture, the humidity in the transformer that is there, and thereby predict the cycle time of the job, which got delayed. This also has enabled reduction in our fault levels of the transformers, various drastically. And in the last 6 months, it has been seen even in the rainy season, the failures are very. As you see, the total thing is there. You see the abnormality here is mentioned in the dashboard itself. Similarly, additive manufacturing I told you, various jobs we have got delivered for the 2-liter impellers, even for the 3D we have done the prototype of it. For turbine nozzles we have done it, for Francis pump runners we have done the simulation part of it, and even we have tried out these impellers at 80,000 RPM. Further, we are trying to introduce robotics as far as possible. Being a discrete manufacturing, it's a very difficult, it's not a line manufacturing like automobiles wherein you can introduce robotics. So, but we are finding a way out so that, especially in hazardous operation, the quality is an issue. We try to take it forward. In transformer tank building, we are doing it. Full transformer tank we are building through. Similarly, for pellet turbine, the buckets are to be for HVF coating of that high velocity oxyflame coating, which is meant for corrosion resistance, is done through robotics and the rotor. So basically, as we see, we have to take care of both the ends of the spectrum, from the state of art machine to the legacy machines, and basically to be up to date, introduce the emerging technologies also. Ultimately, to sustain business, our focus is on execution, expansion, and diversification. And even in the execution part of it, you see that our not only the installation commissioning cycle time is coming down drastically, the expansion and diversification continuing, the establishment of new product technologies, and ultimately it is the people who are behind everything. And BHL invests a lot in training at an in-house training school to sending people to IIMs for training, medium training, and as well as advanced training. For focusing on product quality and digitization, we are harnessing as a business clients. And last but most important, what I am thinking is for Varanasi, this year BHL is coming up our plant at Kharkia, wherein we are going to manufacture electrolyzer, composites, as well as advanced propulsion. Vande Bharat. And this is the model of that plant, which is due to be inaugurated shortly. Thank you very much. In case of any questions, I will be glad to answer.
Thank you very much, Shri Sanjeev Rastogi. You covered the whole spectrum of activities of BHEL, starting from different fields of activity, and also covering the product range which is being proposed by BHEL for the country in various activities, and modernizing the technological background which you had got earlier to a modern type of manufacturing industry, covering all the new machinery, robotics, additive manufacturing technologies, and moving on to IoT area, whereby the efficiency and the downtime is controlled and regulated by the technologies which we have got. I'm sure that this lecture will inspire many of the youngsters to know the type of activities going on in a major industry in India and how they have circumvented all difficulties and come up with solutions which are right there to see. And the effect of that one is being felt at different levels. And I'm sure that youngsters will be inspired by your lecture. Thank you very much for your exposure. Thank you.
Thank you, sir. Thank you very much.
Thank you, sir, for such a wonderful session. After this, we have a lunch break till 2:30 p.m.